Welcome to Analogue Space Mission class. This is called part 4 out of 11. Today we're going to be talking about habitats from tin cans to possibly lava tubes and more. As usual, if you have any questions, you can send me an email. I hope that the exams have been going well so far for you and that you have pleasure with this course. So there are very different kinds of habitats. So you can have inflatable habitats, you can have movable habitats, fixed habitats, habitats that already naturally exist in an existing rock formation, or habitats that you have to build. Actually, that's part of the mission. The habitat's size and general aspect really depend on budget, but also on mission duration, mission purposes. So there's no one habitat fits all. And the same as in space, you wouldn't have one habitat fits all. So it's quite interesting to see the different kinds of them. And today we'll be discussing some of the different habitats, but also what are the models that you actually need and actually do influence the habitats. And today we see on this slide on the left, we've got the hydronaut habitat, which actually goes on the water, and on the right side we've got FMOS, which is in Canada, very much in the Arctic, and obviously much more suitable for cold environment. You can see that it's obviously very, very different. The way you would get out of that habitat, the way you would get to it, actually already changes the way the habitat is built, the way it's supposed to work. So, some of the criteria and parameters for analog habitats. Firstly, the location. Is it isolated? You're going to be isolated, but in a very, very mild environment. Doesn't need to be an extreme environment, which is the second criteria. Are you going to be in the cold? Are you going to be in very, very warm, very dry, very humid? Why is that important? It's important from an astronaut standpoint. So, for example, are you going to simulate being in a harsh environment? But also from a material standpoint. So is your habitat going to undergo some extreme stresses? Because that's going to change the criteria for building it. You cannot just build a random tent in the cold. That's going to kill your astronauts and the material is just not going to last. Same if you have some materials that are exposed to, for example, salt water, and you've got metal that is not inox, for example, well, you might get corrosion and your habitat is not going to last as long as you want to. So in your budget, you have to account for this. The other thing is, are you actually really, really far away? It's really good to have an extreme environment for the simulation of our space mission, because it really does add this extreme environment component, this danger component, but with that comes a problem for logistics. If you are 200 kilometers or 300 kilometers or miles or whatever away from a city, you're going to have to transport all of these by yourself. It also means that your astronauts or any crew that might go there is going to be extremely isolated, and that adds the danger component on a daily basis, not just for the mission, but actually when you build it. If you're missing any tools, you're missing the right screwdriver or hammer or whatever when you're building it, it's also a problem. So just from a logistics standpoint, it's really pretty much a nightmare. I think the FMOS habitat has to be accessible via helicopter from time to time. So yeah, like it does add a little more extreme to the whole mission. And the other thing is, this extreme environment just an extreme environment, or do you want it to be akin to the moon or Mars? Do you want it to look like that? Why is it important? It's not necessarily important per se for the habitat, it's more the location in general and the psyche of the astronauts. You want them to feel like they're on another planet or on another satellite. You want them to really feel as astronauts. If you put them in the jungle, very much unlikely they would be feeling like they're on the moon and Mars. They might be feeling like they're on the planet if they're not used to the jungle. They also might not really enjoy the spiders and snakes that might come with being in a jungle and extra training. But basically, it's quite true that you wouldn't make them feel pretty much on moon or Mars. And that's something that's actually quite interesting, is when you're doing those analog missions, usually what you're missing is a view from planet Earth from your building, you know, it's this component. But if you manage to make them feel like they are on another planet, it really adds an extra dimension. It really adds a, look, I'm doing something real. Look, I'm doing an analog space mission. And look, I feel like I'm in space. So this is always something that's quite interesting, is if you can add really this component I'm away, I'm on another planet, then you might actually be a bit more engaged, you might actually be, or stress a bit more. That's also possible, that you suddenly feel remote. In analog space missions, you tend to know that you're on Earth. For one thing, usually there's no microgravity, and for the other, you usually just had to walk in. It wasn't that complicated to get there, or you had to hike for a few hours. But so having this extreme environment is a very good way to help in tricking the brain to thinking, look, actually we're doing the real thing. And lastly, is the habitat suitable, the location suitable for EVAs? What do I mean by that? If your habitat is in the middle of a city, when you're going to do your EVA, you're going to meet people. You're going to see people walking dogs, you're going to see cars, so you're not necessarily going to feel like you're on another planet. You can always refer to other people as aliens. This is what we did during one of my missions. We were 450 meters on the ground, but we sometimes would meet workers in the tunnel where we were stationed. So we would refer to them as, you know, aliens. Aliens seem friendly, aliens said hi, aliens not communicating. But that obviously kind of breaks the simulation. So if you can really be somewhere where it's extreme environment, so you have a bit of the danger, you have an environment that looks a bit like Moon and Mars, and you can do EVAs, that's fantastic. However, you don't necessarily need to do those EVAs outside. You can also add a module to make that EVA. So if you have, for example, Lunaris Research Station, there are in an old military hangar, aircraft hangar, and yeah, they're not in a very, very big city, but still you could see some cars coming. So what they did is they actually built a huge tent, and this tent is used to simulate an EVA room. So this is one of the solutions that you can actually find. Obviously, if you can just go outside, it's less hassle. Logistically, you don't need to bring, I don't know, 4 or 5 tons of sand to simulate the ground. But yeah, you can also think, well, yeah, we only had to bring 4 or 5 tons of sand instead of driving 250 kilometers in the desert to put our station and possibly, you know, put our astronauts in real danger. So that's for the location. Second criteria, which is quite important, is the crew size. Now, you might not think it's that important, but not only does it change the model size just, you know, for people to be able to do all the experiments, it also means that you need to have possibly more comfort. When you have 6, 7, 8, 9, 10 people, the likelihood that they're all going to get on well is not necessarily going up. And that's the problem, is that you're going to need for people to have more privacy. You're going to need possibly more toilets. During my mission, we had 1 toilet for 6 people, and you think it's enough, but honestly, sometimes it's really a hassle, because like you can't really take your time. It's really just, okay, you there 30 seconds, and bam, there's somebody knocking on the door, like, let me in, it's my turn. And that can be a bit problematic, and if you were to be 10 or 12, suddenly you need 2 of them. Also, you need more maintenance. Oxygen wise, if you were to have a pressurized environment, it means also more oxygen that you need, and with that comes more storage. You need more food. Are you going to be able to store everything? You need to monitor more, etc., etc. So the crew size is not just size from storing the people, it's everything with having those people, from psychological interaction to food and to just systems in general. You can also think from a flight plan standpoint. Obviously, you need people to be, you know, occupied at most times, and it's very unlikely that the experiment tent will just double in size because you have more crew. What might happen is that you just will have crew during exercise while others do experiments. But if your exercise room is very, very narrow, you possibly can't have 2 or 3 people in there. Maybe you can only put 1. So what are the others doing? Maybe they're not being productive, etc., etc. So it really does influence, in general, your mission. And then lastly, again, part of the storage issue is the mission duration and the purposes. Some missions don't really do that many experiments, or mostly psychological experiments where you just need to fill in some forms. But every experiment that like require chemistry, biology, even usually physics, you need equipment normally. You need Ellen Mayers, you need light glasses, You need lab coats, you need sometimes even an extractor, so a gas extractor, you know, in case you're mixing chemicals, sometimes microscope, whatever it needs, you need space, okay? You need space for this. And usually if you're working with dangerous products, you're also going to try to maybe contain it. So you might want a separate module for that. If you don't have that many experiments, then it's not really a problem, but most missions do have experiments that go with it. So this is one of the big points. Now, so we did talk about location. So let's just have a look about logistics, design, psychologically and technically testing, like, you know, is it akin or not to the moon or Mars? Like, does it seem like a real space mission or not? EVAs, do we get to do EVAs or not? And then danger, is it high or not? So, if we're in a remote place, logistics are hard. You have to get all the way there, you have to pay gas, you have to be extremely organized, so your checklist needs to be top notch, because if you're 250 or 300 kilometers away from the next screwdriver, you better not forget it. And you might think it's not a big deal, but actually when you have truck after truck after truck of equipment and you're very tight on the budget, which is often the case for Analogue space mission. Remember, a lot of Analogue space mission are just, you know, volunteers working on it. So you don't have the same budget as does ESA or NASA or JAXA. And you don't have the same facilities. You have sometimes to build your own facilities. So something like a screwdriver that is $40, if you forget it, it can actually really impact the mission. You try to find a way to make it work, but yeah, from a logistics standpoint, you're going to make sure that your to-do list and your inventory is complete and top-notch. Then from a design standpoint, it can be difficult, hard, like it's not because you're in a remote area that it's necessarily extreme environment. So again, like you could have a very simple bunker, or you can have some containers. Some people are looking into making habitats made from containers. You put 3 or 4 containers, you put them together, you solder them, or whatever you want to do with them, and then technically you've got a habitat. It depends how creative you want to be, depends how extensive you want a habitat to be. So it's moderate to hard because obviously you need to bring it up, and usually you could say extreme environment, but yeah, it's not necessarily the hardest thing. Psychology and technically testing, it's good. Why is it good? Having, again, this logistic standpoint, you have to think, when you're on the ISS, you have somebody on Earth in a mission control center who tells you where every tool is. They will tell you the number, they will make you scan it, and if you lose it, then it's problematic. Was it a screw? No, was it not a screwdriver? It was an actual drill that was missing for several years and was found then by Team Peak sometimes when it was floating up there. So sometimes that can happen. You could think, well, you know, having to make this extra effort actually is very good preparation. If we were to go to space, this is how we would do it. We would really be like checking everything, make sure we got all the tools once we get there. So it's a good way to test it. And psychologically, again, if you can't see anyone walking their dogs, if you can't have your family saying hello, I'm here, blah blah, then again, it's a very good exercise. EVAs, good again. If you're in a remote, it's not necessarily the best because you're not necessarily in an extreme environment, but it's good in the way that you have this isolation factor. Danger, moderate, high. Again, the problem with being in a remote location is if you need, for example, an ambulance, if you've got an astronaut who's got a problem, they're going to take some time to get there. And it depends also where your mission control center is. If your mission control center has several medics who can help, then it's already easier if you closer. But if your mission control center is, you know, in the main city 250k away, then it's already much more dangerous in that regard. So it's not necessarily dangerous in a way that, you know, it's extreme environment or that you're gonna mess up. It's just because you're far away from help. Extreme environment already is high up in danger and logistics. So it's the same problem from a logistics standpoint. Plus you have to think, okay, how do we make sure that, you know, there's no extra danger? So what kind of equipment are we going to need to protect the astronauts and to protect the facility? And that actually also impacts the design. So you have to think, okay, we're going to need maybe more heating or more cooling systems. We're going to need different spacesuits. We're going to need corrosion resistance maybe, or heat resistance, or sun resistance, UV light resistance. But from psychological and technical testing, that's amazing because you have to be even more prepared. You have to work even harder to make it work. And for the EVAs, again, it's usually quite good. Means that they're much harder, which is why I put good, hard. It's good in the way that it's a good training. It's hard in the way that it's a little bit more dangerous and more tiring. When we did our Analogue space mission Askepos-1, we had spacesuits that were designed in February. Because of COVID, our mission got moved from April to February and then from February to July. And the spacesuits we had were made for February. They were made to keep us warm. But in July, the temperature went up to, I think, 27, 28 degrees instead of 5, 6 degrees, or maybe 10. And yeah, it was pretty warm. It wasn't dangerous because we didn't push ourselves too much, but we did come back and we were completely drenched in sweat. And that's the kind of thing that you might have, and if you go in an even more extreme environment, if you go in a desert where it's like 35, 40 degrees, you're going to really have to adapt. You're going to have to make sure that you have good cooling systems, and that really does impact the design, etc. But also impacts your EVAs. And danger, again, moderate to high. Depends, like if you're going really, really far away and it's really cold, or you're just going, you know, somewhere where it's very, very cold. Normally, extreme environment does coincide with remote, but you do have sometimes cities that are really close and, you know, they're just used to that extreme environment. So yeah, so that's for that. Near inner city, logistics, quite easy. If you're missing something, you just go next to next gas station, you can get stuff that you might need. Design, easy and moderate, depends. Obviously if you want to build a chateau on the moon, then you have a different design. But usually it's quite easy because you don't need to account for extreme environment, you don't need to account for any redundancy because you're in a remote location, and it makes everything quite easier. Psychological and technical testing, not so good. Why? Again, no isolation, no real danger, so you're not really testing everything, you're not pushing yourself to your limits. And for EVAs, again, same problem. You might meet someone, you might not really feel on the moon if you're working on concrete, or maybe it's the moon in 100 years when we, you know, started building everywhere. It's not really the same thing. And again, danger is quite low. It's an advantage though. If you, for example, starting, if you want to have a lot of missions, if you're focusing more on the experiment side of things, you know, experiments in the tent, you can still do some absolutely amazing things. So again, Lunaris, for example, was an extremely good Analogue space mission resort, but it's in a city. It's just like a 10-minute drive or 15-minute drive from the city center. You can get there by car. There's not a lot of visitors, but there are, but the astronauts actually never get out of the habitat. They have an EVA, you know, sand pits, so they don't actually get affected by that much. And yeah, you can do some really, really good things. It's just obviously if you're really counting on the EVA side, being in a city and being in a non-extreme environment does change things a bit. And then underwater, well, that's probably one of the most hardcore, I would say. Logistics are extremely hard, obviously, because you need that. That's one of the only cases where you have really a pressured environment, habitat. The design has to be excellent because if you mess up, people die. So it's actually the only analog habitat where you really, really are in big trouble if you mess up a bit, because you could still try to heat yourself up, you can still try to put some clothes, for example, if one of the cooling system fail when you are in desert or, you know, in a very cool environment, you can remove and put some clothes, you can try to find a way. You are on earth, on ground, you can get out, you can breathe. But if you are in a completely closed space, and if you were to open the airlock without any safety or with a damaged door, you would drown. And that actually really changes things. That makes everything much more dangerous. Means the design has to be top-notch, means the logistics have to be good, because you don't want to be going up and down in the water 20 times just because you forgot, again, the screwdriver. But it's excellent for EVAs. I mean, you're floating, so you've got a bit more of the space feeling. You might not feel like you're on another planet possibly, but it's still very, very interesting from a danger point of view. So yeah, this is more a summary of like how the different locations do influence habitats. Now, before I mentioned inflatable habitats, and maybe you don't know what that is. Inflatable habitats are those kind of habitats that you could pressurize and, you know, serve as protection. They could contain, you know, the right amount of oxygen that you would need to survive. Obviously, so you would have an artificial atmosphere, and you would use these in lava tubes. So these on the right side, you can see a inflatable habitat from Chile in 2021 that they used in lava tubes in Iceland. These are examples of how you can, you know, use a portable habitat and then spend a night there when you're exploring the moon or Mars, for example. Obviously, if you were to have this habitat and there's a storm or there's a radiation, then you are obviously in real trouble. So these are to be used in a existing crust of a habitat, like a lava tube or a rock formation or anything that you would have. But they exist and they're very good to test things. So for example, in Chile, the goal was you had 8 hours of autonomy of oxygen, you had to carry this, you had to inflate the habitat, and it's a way to really test, okay, can we do this? Can we go and explore the moon? Can we go and explore Mars? Makes it very, very interesting. Usually the missions are much shorter also. Obviously you're not going to spend like 3 months in this, well, hopefully not for you, but it makes a very, very much different aspects of Analog space mission. And on the left side you can see Mars 500. I mentioned already in past classes that it was a mission that had a duration of 517 days, 520 days or so in 2011, and those missions basically you so long, and then you're simulating really the journey to Mars and the way back. You need this rigid structure. Why? You need the habitat to last. Just from Earth kind of influences, you might get damage on it. You might not be able to keep it okay. If you had a tent like this for 520 days, like for Chile, it will probably get damaged quite quickly. Mars 500, it needed to last, it needed to be protected, it needed to be isolated. So obviously, like, a rigid habitat made sense. It made totally sense because also you're not going to move it every 2 or 3 weeks. You need people to be isolated. So that's basically the differences between why we have rigid and why we have inflatable habitats. Now we do a little case study again about Mars 500. So here you can see like a kind of schematic view of what the module was. Again, it was placed in Russia, but it was a collaborative international effort, and it was quite interesting. So the red module was 100 square meters, and it was simulating the Martian soils at -60 degrees. So this is cool. Why is it cool? Obviously they were in this rigid structure. I think they were quite in a city, so it means you can't really go outside to do that EVA, and that was really an extremely important study. It was really the main efforts to really see if we could do long duration space exploration. And the problem is if you were to ask them to go outside and do an EVA, it would probably really much break the simulation. By doing this EVA kind of module, you actually really help the astronauts stay into this mindset that we are in a mission. It means they don't see anyone, they don't feel anything, and by keeping it at -60 degrees in a non-breathable atmosphere, you make sure they really feel like, okay, I'm in danger, this is the real thing. There are 2 greenhouses and a sports room. Again, we're going to discuss this. Obviously, sports will be extremely important in space to maintain a cardiovascular system. You can argue that if you don't come back, it might not be that useful, but hopefully everybody will come back from Mars. And the greenhouse is obviously if you want to grow your food for a long time, then it's quite important. But for this, there's also actually a storage module of 250 square meters for food, tools, and water. I couldn't imagine what would happen if that failed. I don't know if you would abort the Analogue mission if you were 250 days into it and, I don't know, mice got in and just damaged the food, but I guess you have small compartments. I had a medical module. I guess for like very, very long testing like this, you do need more intensive medical examination. Also, psychological and biological testing get more important with longer duration missions. The main module contained a commoner's room of 4.5 square meters. You can always argue why does the commoner get 4.5 and the others 3 square meters, but you know, everybody does their own thing. And they were closed by curtains, and there was a playroom and a control center. Curtains, why? Obviously you want people to have privacy a little bit, not necessarily, you know, have closed room completely, but you want people to be able to take some time off, and especially with long duration missions. That mission in the last weeks and months, some of them started experiencing some form of depression and tiredness, and I guess they needed that privacy more than ever. There's a landing module where they can pretend to, land on Moon and Mars, and they can stay there for some time. So quite interesting also, because obviously you're not simulating just any mission with this one. In this, you really do simulate the whole journey and then the mission on Mars and then coming back. So this landing module is really an extra. It's not something that we have on all analog habitats. It's really specific to this one, but it's quite an interesting one. And yeah, so this is a total of 550 square meters, so quite huge, and there were 6 astronauts in the whole base. Now, the mission duration and purpose. So I did mention before how the mission duration was affecting things. Obviously, the longer the mission is, the more time you actually need for like crew privacy and more space you actually need also for them. You need them to stay, well, it's easy to stay focused on a mission that's only 2 days or a week long. In a mission where you're going to be 6 months, a year away from your family, from your friends, from I don't know, your job, depending what it is, you're going to need more and more support. You're going to need more and more time where you can just do whatever you want. So if you see a mission that's 48 hours, you're not going to need to have a movie room. You're not going to need to be able to read a book. However, a mission that's 6 months long, you might maybe do leisure center or just wellness center, whatever it is for the astronauts to feel well. Also, long mission duration means tougher logistics. 2-day missions you can try to make do, might kind of not make experiments fulfilling. So for example, if you're missing the equipment, maybe one experiment will get damaged. But if you got 6 months or a year of worth experiments and you're missing quite a few things, then it's several people who will be impacted by this, because it's several experiments and several people who developed them behind it. Also, just for safety, it's just better for you to make sure that you get all your logistics absolutely on point. So you need better storage and control, you need understanding of your inventory, all the tools and materials that you might need. And another thing that you can actually do is call for refueling. So if you're going to have a mission that's a year long or 6 months or even 2 months, you could do refueling. So you could say, well, we don't want a storage area that's too big. Instead, midpoint will just come back and get the waste out and replace it, or leave the waste and just replace it with food. On the ISS, you do have some cargo ships that come up and they, you can remove your waste, it usually burns in the atmosphere, or you can return stuff if it's experiments, and instead you got another spaceship that docks and brings some fresh food. Usually you got 1 to 3 days of fresh fruits, and you're really happy about that. And it doesn't necessarily break the simulation that you do this. It's just if you were to say, well, that cargo was going to take a few days to arrive, and once it's docked, you still have to wait a few hours, it might be a good one. However, it's true that if you were to be flying to Mars for 6 months, it's quite likely that you'd be refueling quite a bit. So yeah, you have to take that into consideration. What kind of missions are you doing? Are you on the Moon? Are you on Mars? How long are you going to do that? And what aspect of the space mission do you really want to recreate when you do this? Then the experiments. So as mentioned, really depends on the type. If you have a lot of experiments, if you have chemical, biological experiments, you're going to need a lab. You're going to need something that's separate, just for hygiene and health reasons. Even if you were to just grow plants, you don't know, depending on what kind of plants you have, if you want to protect the astronauts, you don't want to have the lab next to the kitchen, for example. Also, you want to have a semi-controlled environment. So obviously it's not as if you might have a complete clean room in our mission, because clean rooms are extremely expensive. But you do want to have something that is actually quite good and quite akin to a lab, because this is what you would like to have in a spaceship. You wouldn't be doing experiments just on the ground, or, well, if you're doing geology, yes, you would. But in a lab, you usually have a very controlled environment. So you will want to have a separate room, and possibly quite a big one if you have a lot of experiments. Now, what's very interesting with habitats is architecture, and if you look now in the past years, there's been an absolute massive increase in space architecture project, presentation. Everybody comes up with a different design, and I think it must be quite exciting. I'm not an architect myself, but I could see how it's a new challenge. It's very, very interesting, and you can think about all those futuristic places. Nobody's going to say, oh, that doesn't look enough like the original country, this doesn't fit the style. You're the first one now. Who's going to say no? The aliens? So that's the thing. It's quite interesting to see the different designs, and obviously there's like a different constraint. But there's a very big difference between these images that you see of, you know, conceptual design on Moon and Mars and analog space missions. Again, the budget. You don't need something like this on an analog mission. You don't need it to look nice. Usually it's not billionaires who go and do analog space missions, so you don't have the budget. However, you can still think about what you can do and how you can actually change things. For example, you can think about how the colors and just the general inside design can affect astronaut well-being. And it's quite interesting to see like how colors could really affect the mood, and also think about stuff that is quite simple, but insulation, so noise cancelling structures can really help. On the ISS, I think you've got always, I think it's about 75-80 decibels of noise all the time, and that obviously can be quite tiring for the astronauts. So in analog space missions, you usually don't have the same systems, ventilation systems, but you might want to try some of those cancelling systems to see, okay, do they work? How does the analog astronaut feel? Is it something that we could then implement in space? And we can test that on Earth. So there's mandatory and non-mandatory modules in analog habitats. So we did mention before that obviously some of those missions needed EVA's module and others didn't. So these are already some of the things that are non-mandatory. It depends on the location, depends on the mission focus. Another non-mandatory module is, for example, crops module. By crops, what I mean is agricultural crops. So if you are trying to grow your own plants, your own foods, and you're going to need a special room for that module, part of a module. But it's actually not something that all analog space missions have. I think only Habitat Mater has it all the time. High seas tend to have a lot of crops growing, but it's not something that is, you know, just very, very much usual. And normally you don't have a module just for it. Relaxing quarters, something we already discussed before. It's mostly needed depending on the mission duration. It's always nice to have, but obviously if you need some more space for example, for foods, I think people would be happier to have more food than have more relaxing quarters in analog missions, because it tends to be quite tough. In storage, again, it really depends. You might store more stuff. For example, you might think, well, actually for astronauts, you might want to take some personal objects like games or a guitar or a keyboard or whatever it is. So having storage space is nice. It means you're safer, means, you know, you're less likely to be on edge because you're missing something, but also means additional logistics, additional room that you need to build. Usually increases the price of the habitat, so it's quite a compromise that you need to find, and some missions are quite short, so the storage is not really needed. You can store food or, you know, personal items next to your sleeping quarters or your kitchen. A communication room, I'll put it in between the non-mandatory and mandatory. It's in the way that you don't necessarily need a whole room for that. Usually just a computer or a few computers and a few webcams are sufficient. You need obviously contact with Mission Control Center. You need to talk to them quite a lot, but it's unlikely that you would go back and forth just to a communication room. Normally you might just have computers in the different locations that you have, so you can really just communicate where you are from and just say, well, look, I'm in the experiment lab right now, I'm doing this, and you're not just running around with your Beshers and Ellen Mayers full of, you know, dangerous substances back to a communication room saying, oh, can you call the PI because that experiment is not working, right? So that actually makes it easier if you have just communication spread out. But you could technically have a communication room, and I could imagine if you were to do a long mission, you might actually just do all the reports there. Having a really nice big screen so you can see people also means if you were to have, for example, communication with your family, you would have more than just a very small screen, which you don't really have a private space for. So again, communication room depends more on the mission duration than on the mission type. Experiment tents, we mentioned that again. Again, depends really on the experiments you have and how many you have, and the exercise room. So in inflatable habitats, for example, you wouldn't have an exercise room. Your exercise is probably going to be the really tough EVA you're going to be doing to install the habitat. But in long duration missions, you would need exercise room. The exercise room can also just be part of another room. It doesn't need to be an independent module, which is why it's a bit in the middle, but you will have some exercises, you will have some tools, you will have, I don't know, weights or a treadmill, things like this. So you will have them, not necessarily an independent module completely, but you will have them. Kitchen is quite interesting. So obviously food, extremely important. You don't want your crew to be on edge just because they don't have enough food. You want them to be healthy. Sometimes it's nice to have some little snacks to keep everybody happy, but also has a very much social components. So in some kitchens, for example, we have like just a table that helps the whole crew to be together. You can usually influence the flight plan to make sure the whole crew eats together. That means more social cohesion, more contact, social contact. So it's, yeah, it's something that you can take into account when you create your habitat. Just thinking, okay, do I want to have a main kitchen table? Do I want people to meet there? Do I want it to be a social spot? Usually kitchens are social spots. So this was actually studied to see, yeah, we can see that this is where the astronauts actually interact the most. So it's actually quite an important element. The airlock. Why is it mandatory? So you don't necessarily need an airlock because sometimes you won't be doing EVAs, but you do need an airlock when you come inside the habitat and when you come out. It doesn't need to be pressurized, it just needs to be a physical demarcation, like saying, well, we have this door, this is outside, this is moon, this is Mars, and this is inside, this is base, this is spacecraft, this is habitat. If you don't have airlock, if you just have a normal door that's not even painted, which is not even written airlock, you probably diminish really the social, psychological components of thinking, well, we have this separation, you have this thing that really tells you now you're in the mission, now you're here. If you go out with a spacesuit, danger, danger. And it's quite easy to make an airlock. I mean, you can take a door, paint it red, or just put some tape. You don't need to make a really big one. You don't need for it to be two separate doors where you pressurize in between. I mean, the door that we had for Asclepios, so the outer door was really, really good. It was really, you had to, turn the lever to close it. The inner door, the door handle kept, breaking. So actually I was trying to repair it with a bit of wire. So it kind of would break a little bit, the simulation, but the fact that we had two different doors and the second one was really sturdy, the one to the outside world, actually made it quite interesting and much more real. It really made us excited when we're going in and when we're going out. We're thinking, okay, we're really crossing the threshold to the outside world. Sleeping quarters, I didn't put it in completely mandatory because technically you could have sleeping quarters where you just, put the bed back up or have sleeping pods or bean bags where you sleep. Not really recommended, probably going to break your back if you do that. But you could technically have sleeping quarters that move around. But I think it's actually good to have sleeping quarters in a way that you could store things, so you can store your private things. It also could be your privacy room, so you don't need to do a separate compartment for your privacy. And usually it's also just safer and more hygienic if you know where you're sleeping. So I recommend it, but again, not something that is completely mandatory. One that is one for hygiene. I mean, if you have a toilet, normally you're gonna have a physical toilet. If you were to move it around, that's not gonna be hygienic. And also you need, again, some privacy for people to get changed and to wash. Obviously, this is not necessarily a shower. It can be done with wipes. It needs to be done. But if you don't have a cubicle and if you don't have a sleeping quarter, and even a sleeping quarter, that's not where you want to be doing like this and trying to clean yourself. You want to have a separate room where you can really just, really clean yourself, separate it completely, and then when you go to bed, you clean, or when you wake up from bed, you go and get cleaned, but you don't want to be mixing the two. So the hygiene with a toilet or bathroom or both is extremely important. This is something that is very difficult to mix with anything else. You don't want that in the kitchen, that's not safe. You don't want that with the experiments, it's not safe. You don't want sleeping quarters, it's not recommended. We had it next to the airlock, but it wasn't in the airlock, but you could technically put it there. But I do hope that there's no depressurization when you're on the John, because that might be actually a very tough experience. Now, how can we make those habitats more realistic? So I mentioned, obviously, we have limitations of budget in our space missions. One budget thing and danger thing that actually limits it is, for example, having a pressurized habitat. So we didn't mention for underwater, obviously, you need to have a controlled airlock. But for most habitats, you could technically just open the door. It makes it way easier in case it's an emergency, and also means you don't need any like pumps or just closed systems. You can basically have the ground and build something on it, put a container on top of it without any problem. But if you were to pressurize a habitat, it would actually mean that you would have a time delay between when you can go in and come out, not just a protocol one, an actual one. You wouldn't be able to open the door. So that's something that is quite interesting. Some analog space missions are trying to implement that right now, so it's quite interesting. We'll see what comes out in the next years. But yeah, so this is one thing that you can actually work on. Then there's a view on extreme environment or none at all. By this, what I mean is you won't have necessarily a window to outside, and that's actually a good thing. If you are supposed to be underground in a lava tube, you're not going to be able to see outside. And when you look outside, you can't see grass or trees, yeah, you're not going to feel like you're on the moon at all. So not having this view, or having the view only on extreme environment, is something that you can try to implement. Usually it's the case, but you can still, a bit more. And then having an EVA module airlock towards an extreme environment, obviously always a plus. I mean, this is something that is obviously done a lot in our missions, but it's something that you can try to implement a bit more. And then simulating habitat maintenance and emergencies. I think this is something that some missions do work on, but it's not the norm for all analog missions. And that's actually one of the biggest things. On the moon and Mars, you need to check your habitat a lot. Your habitat is your home. Your habitat is your spacesuits, your spacecraft. If it's not safe, you die. You die, or you get in a spacesuit until your oxygen runs out, and then you die. So it's your home, and you have to take care of it. You can't just say, oh, I'm not vacuum cleaning, I'm not checking that leak. No, you have to. It's priority. So this stuff that's already done in our missions, like, you check the CO2 levels and check the temperature. But it's actually difficult to get into habits of checking for leaks and stuff like that when you're on Earth, because obviously you don't have the same danger. It doesn't have the same connotation as it would have in space. Underwater, though, it already has a much more realistic impact. It has a much more realistic connotation, but it is something that needs to be really worked on. So, for example, during Algebra, we had a moonquake alert system experiment, which meant that we had a simulation of a moonquake. I got up at 2:30 in the morning, and we had some people evacuating in toilets, and then I, as the commander, and my base engineer, we had to put the spacesuits. We then got the go from Mission Control Center, and we had to pretend to see if there were cracks. We had to check on the experiments, we had to check on communication systems, etc., etc. And that was quite interesting, but you could still feel it was a bit difficult to really pretend something had happened, because obviously we didn't feel anything. We just got a massive alarm that woke up everyone, but nothing was shaking. There was no real damage. But it's a very good exercise still. It's good because it makes you aware that actually this could be happening on the moon and Mars, and you need to be ready for it, and you need to take care of your home. So yeah, so this is a way to make habitats more realistic, is to really think about how would you actually care for them, and what would you need to do. So why are we testing those habitats again? So except for this danger, well, the thing is, on the left side we have, well, I don't call it a tin can because it's actually quite huge, but you got the International Space Station. And the International Space Station is, can be quite loud, and it's temporary. I mean, you have people staying maybe a year over there, a bit more, but it's not everyone. It's astronauts. Whereas on the moon and Mars, we're gonna aim to have people going there who will be technically astronauts because they are on another planetary body, but they're not astronauts per career. The people who are going to live there. Well, at least that's what we hope for. And that means that the habitats that you're building are actually quite different. They're supposed to be a bit cozier, it's supposed to make you live there. Also, there's a bit of gravity, so it means you're not going to be just floating around all the time. You're going to have to, you're going to be able to actually do a bit more than you might do on the International Space Station, but not more of a normal life. And you want to stay there longer. So that's why we test those in analog space missions, because the focus is actually quite different than if you were just saying, well, that's for sure temporary. And it's actually very, very exciting, I think. You see some really, really cool design that you can see on the right. That's inside the lava tube. But yeah, so it changes a bit of perspective, and that's why we call them tin cans to, analog habitats. Now, there's an example of a moon habitat project that's in development, so that's not an analog mission. It's just to give you an idea of some of the concepts that are being worked on, and one is NASA's Smart Hubs. It's led by RETH project, and basically the Smart Hubs could host 8 to 10 people. They will have modules for sleeping, for eating, for hygiene, exercising, leisure, storage, research, crops, agricultural crops, spiders, And what I found really interesting is the design was not focused on the astronaut itself, but more on like the systems and the habitats. So for example, they wanted resilient systems, and they want to avoid and shield from hazards. So they don't want any radiation, protection from earthquakes, well, moonquakes, and the use of lava tubes to this effect. So I found that quite interesting, that it's really much more on the sturdiness of the habitat. And then there's the situational awareness. So sometimes astronauts would leave those habitats alone, and then you need to be able to control them. You need to make sure they're still fit for use. And to that effect, you use sensors to monitor temperature and pressure, but also the air composition, and any leaks, any radiation, any damages. So this is one way where we can start caring for our habitats and make the job also even easier. It's just to have this automatic testing. And then the robotic maintenance. Obviously, we can't always do all the jobs of maintenance. There's something, even on Earth, you don't do all the construction yourself if you can. But also with microgravity or reduced gravity, it's going to be actually more complicated to do it. It'd be easier to lift things, but it's more likely that you will be unstable. So actually having robots helping in the maintenance and control and upgrade of the facility is a big plus. So yeah, so this is an example. You can have a look into NASA Smart Hubs project. Very excited to see how it's going to look like. But yeah, I think it's quite interesting to see that they have really this focus on the maintenance and just safety aspect much more than thinking about an artistic design or how you can improve life. Because if we were to look back into our slide with mandatory and non-mandatory modules, in the Analogue Hub, the mandatory modules is all astronaut focused. It's all about how you make them survive. And there you can see that the focus is very much on the habitat itself survival. But it's normal. It's the smart hubs. Once the smart hub works, the astronaut will survive and be fine. And then it's just up to you what you want to put in there. But yeah, so that's quite interesting. So this is for today. Do you have a look at the different habitats that exist? Do you have a look at the different missions? Obviously you have the list of different missions, not exhaustive list obviously, but have a look and see what you would be able to survive in. Would you prefer a tin can? Would you prefer a very, very roomy spaceship that you have to really clean all the time? And if you have any cool architecture project, the International Astronautical Congress in Paris in 2022 had some very, very interesting designs. Not sure if they would all work, but from an architecture standpoint, it was quite interesting. So yeah, I hope you have a lovely time and learning this and enjoy.